This question is from GATE 2014 Mechanical Engineering paper, Set 3, question number 46. At the inlet of an axial impulse turbine rotor, the blade linear speed is 25 meter per second, magnitude of absolute velocity is 100 meter per second, and the angle between them is 25 degree. The relative velocity and the axial component of velocity remain the same between the inlet and outlet of the blades. The blade inlet and outlet velocity triangles are shown in the figure. Assuming no losses, the specific work in joule per kg is dash. Let's find out the specific work here. We can write the given things from the figure. Blade velocity u is given to be 25 meter per second. V1 inlet velocity is given to be 100 meter per second. So V1 is 100. V2 is 58.6 meter per second. Relative velocities are equal to each other. So VR1 equal to VR2 equal to 78 meter per second. We need to find out the work done per unit mass, that is specific work. Let it be W. Now it's given that there are no frictional losses. That means the flow velocities are equal to each other. Relative velocities are already given equal to each other. So specific work will be given as blade velocity U into the sum of whirl velocities at inlet and at outlet. So we need to find the whirl velocities in order to find out the specific work. Now in the figure we can draw the flow velocities and the whirl velocity. So flow velocity will be this Vf1 and this being Vf2. Whirl velocity can be shown as this is Vw1 and this is Vw2 as per the velocity triangles given. From the figure we can write Vw1 is equal to, Vw1 will be V1 cos of this angle. So it will be V1 cos 25 degree, which is equal to V1 is 100 into cos 25. We get Vw1 value to be 90.63 meter per second. Now we have to find out Vw2. So Vw2 equal to, from this figure we can say to find Vw2 either we can use this angle and the flow velocity, but we don't know the flow velocity. We know the outlet velocity V2 58.6. So we can use V2 and Vf2 to find out the whirl velocity at outlet. So this being a right angle triangle, V2 is hypotenuse and Vf2 is the height. So we have the relationship by Pythagoras theorem. Vw2 will be equal to root over V2 square minus Vf2 square. We know Vf2 is equal to Vf1. And Vf1 from this bigger triangle, V1 being the hypotenuse, we know this angle is 25 degrees. So Vf1 will be V1 sine 25 degree. Vf2 is equal to Vf1, which is equal to V1 sine 25 degree. Just substituting all the values here, we get Vw2 is equal to root over 58.6 square minus 100 sine 25 degree. This when calculated in digital calculator gives us Vw2 is 40.59 meter per second. So we can now substitute Vw1 and Vw2 here to find out the specific work. Specific work W is equal to 25 into 90.63 plus 40.59. W turns out to be 3280.608 joule per kg. So let's go back and fill in the answer. Assuming no losses, specific work in joule per kg is 3280.608. You can also write it as 61 joule per kg. To learn about impulse steam turbine in detail and to study its velocity diagrams, you can refer to the NPTEL video lecture 12, impulse steam turbine velocity diagrams, work transfer, blade efficiency, from the course Applied Thermodynamics. The course is by Professor Pranab K. Mondal. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.